Welcome to our second demo, the Perimetric Blob. The blob machine is the upper left icon, which you can drag onto the canvas. And what you're looking at is a mesh. So the best way to visualize it is to type mesh and obtain a mesh edges component so that you can actually see the edges of the mesh. The second thing to do is to extract from the geo parameter the actual geometries that determine this irregular volume. First thing to do is to right-click on the component you've just extracted and make sure that it's previewed. And then you can actually see the three geometries right there, these two parallelepipedic volumes and the pyramid that you see over here. The best way to manipulate this is to simply bake them, as I'm doing now, on any given layer. And once you've baked them and you can actually see them, you simply select them and reassign them to the component as multiple geometries, so that now you can manipulate the parameters of the mesh by manipulating directly the primitives. Okay? So you can add another one. If I copy the tallest element, okay, up to the edge over here, okay. If I scale it using the scale 1D function, which scales it along the one dimension, in this case, the z-axis, and then select all four primitives and reassign them by right-clicking on the geometry component as multiple geometries to determine, the outline of the so-called sarin wrap of the perimetric blob. Of course, the next thing to look at now is what the parameters of these are. So the first thing is you see the shrink, the bound shrinkage is a value determined between 0 and 1. So the best way to test it is to create a slider with 2 decimals, so that you can look at the range of transformations from the minimal condition that you have now all the way to the standard elementary configuration, which consists in creating the minimum bounding box for the relative position of these 4 elements in space. So if you do move one of them now, you see the minimum bounding box is also obviously adjusting accordingly, so here. Or we could, for instance, rotate this one and move it to adjust the bounding box. Now, conversely, if you reduce the shrinkage, you default back to the minimum configuration, which is the one that you see over here. There are 2 types of wrapping, as it were. The first one is the box, and that's to be found under the parameter type. And you can toggle between the box and the sphere simply by creating a Boolean toggle. So you just type Boolean toggle here and obtain this component, which defaults to false, which is 0, which is the type of the box that you see there. But if you set it to true and then start going back to the original extended configuration, you'll see that now, instead of defaulting to a box, we're defaulting to a kind of geodesic sphere with uneven triangulation. So these are the 2 computational models that are actually baked into this particular transformation. The final parameter you may want to look at is the actual parameter of the mesh subdivision, which is again a real number between 0 and 1, okay, which I'm going to type with a couple of decimals so that we can go over the range of the transformations. And of course, these only work with, if you give enough surface to play with. So we're going to revert to the box because the sphere really is way too dense. And then you can see that the subdivision allows you to reconfigure the actual density of the mesh as needed. So this again is a mesh, so you could very easily create a mesh component and extract the geometry, bake it as it were, you see, which I'm doing now on layer 2. Okay, and when it is baked, I'm going to move it out of the way. You see, you can post-produce it, obviously. If you don't care about the mesh, you could mesh to NURB, so that you actually produce a NURB, and now cell meshes by typing cell M and deleting the mesh, so that you're left just with a brep that you can edit with all the power of the Rhino commands. And now, of course, remember that this volume is directly determined by these minimal internal relations between these internal components. Thank you.